Hello, last video before I am back with you again. Um, so today we're going to be covering combining random variables. Combining random variables. Um, Hang in there. I'll be back soon. Um, Actually, you might even prefer this because then you have a little bit more time to work during class. But when I get back, you'll be able to ask a bunch of questions. We'll have a day just for you to ask questions. Um, okay, so yesterday we talked about transformations. Now we're going to talk about combining random variables. So this isn't just adding or subtracting a constant, but adding or subtracting another variable. So, for instance, if we had Pete's Jeep tours, right? And let's say Pete's sister, Erin, also runs a Jeep tour in another part of the country. And let's let her like random variable be Y, right? For the number of passengers that are selected for each of like Erin's adventures. Okay. Um, Now her car is a little bit smaller, so she is only able to fit five. Okay, in her Jeep. Um, so what if I wanted to find like what is the total like expected value for both of these together, for both Pete and Aaron together? Like, how would I do that? Right? Um, like, so what's like if we wanted to say, okay, well, what what is it? How many passengers do they have together? And then even like, well, what's the difference between Pete and Aaron? Does Pete average more and Aaron average less, or does Aaron average less and and Pete average more? So on and so forth. Well, when you're combining them, you could think of it this way, like the rule of thumb is that if they're independent, right? If they don't depend on each other, they're not taking each other's customers, whatnot. Actually, remember, probability of A is equal to the probability of A given B. That's the definition of independence. But if the two events are independent, then the mean of the sum or the mean of Pete and Aaron is going to be just their two expected values added up. So the mean of X plus the mean of Y. And the difference is just going to be the mean of X minus the mean of Y. Okay. And it would you literally just calculate their two expected values separately, and then you add them or subtract them. So let's even go further, right? You can even do this if you were like transforming the random variable as is. So Pete charges 150 per passenger and Aaron charges 175 per passenger on her Jeep tour. If you calculate, right, the amount of money that Aaron collects on a randomly selected day, using 175, you find her mean is 142.50. So if you wanted to calculate, okay, well, what's the average that they make together? It should make sense that you would just add the 562.50 to the 542.50. Okay, and you get that total to be 1,105. So on average, if their average profits per day in the long run is going to be 1,105 per day together. Now, if you wanted to take into account their standard deviation, right? Um, this is oh yeah. This is where it's important that they're independent. right? And I actually already mentioned this already earlier, right? Probability of A and B, probability of A times the probability of B. There are two different ways that you can get it, but the main thing I want you to remember, I don't actually want you to remember this. What I want you to remember is the formula. So if you were to do it like by hand, you would have to do each of them one by one. But if you actually see how they're related, if you were to look at the formula, you would find that the the variance of the sum is equal to the variance of x plus the variance of y. So if you were to find the standard deviation of the sum, you would just need to take the variance of x plus the variance of y and take the square root. Okay? I didn't want to get into the nitty gritty of it because in the end, it doesn't matter. Like if you want, you can look through the PowerPoint again, and I can talk about it, but I just don't want to confuse you more. I just want you to remember this formula. Okay. For expected value, when you combine two means, you just add the two expected values or subtract the two expected values. And when you are taking the standard deviation of them, then you want to find the sum of the variances and then you want to take the square root. Okay? The standard deviations don't add up. You have to use the variance. It's actually very important that you remember that. Okay? Now, interestingly enough, when it comes to the difference, guess what? It's going to be the exact same as the sum. Okay? Now, hopefully this makes sense to you, right? Like, just because you are, when you're like taking the difference of the random variables, it's not gonna, like, you're not gonna subtract spread, right? Like, the spread is still going to increase by whatever amount that you're multiplying by, right? So when you take the difference, you are still going to use the same formula as you did for the sum. Okay. So you would take the variance of x plus the variance of y, and you were to take the square root. Okay. If you were to actually use the formula that we just learned for standard deviation back in 6.1, and you were to like derive this out, you would see that it's the case, right? Whether you subtract or add, when you square it, it's still going to be positive. Therefore, the variance is still going to end up being the sum. That's the best I can do. If you really want to see it, I'll talk to you about it when I get back. So, how does this play out? Okay, overall. So let's take a look. Pete charges $150 per passenger, and Aaron charges $175 per passenger for a G tour. Let's see the amount of money that Pete collects, and the amount of money that Aaron collects on a randomly selected day. From our earlier work, it is easy to show that the standard deviation of C is equal to $163.46, right? Like the combined standard deviation. Oh, sorry, not the combined. Uh, 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 for Pete, and then the standard deviation for Aaron is 165.3. You can assume that the two random variables are dependent. Define D, add the difference as C minus E. Earlier we found that the mean difference was $20. calculate and interpret the standard deviation of D. Okay, so when we do it, what we're going to do is we're going to take the variance, which is 163.46 of Pete, and square it. Then we add it to the variance of Aaron, which is the standard deviation for Aaron, 165.03 squared. We add those together, and then we take the square root. Then we get the standard deviation as 232.28, right? So the difference in the amount that Pete and Aaron collect has a mean difference of $20, but the standard deviation, the average distance from that, plus or minus, is plus or minus $232.28. Hopefully that makes sense to you. If it doesn't, then we'll talk more about meaning when I get back. But for now, focus on knowing how to do the calculations. Okay. What if there are two? Oh, okay. So this is, okay. So if we combine two random variables that are normal, then the combination, the sum or the difference is also, we can expect that to be normally distributed. Okay. Okay. And they would still follow the same rules that like normal distributions would follow for standard mean and standard deviation. Okay. So here is a problem. The diameter C of the top of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inch. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inch. Assume that L and C are independent random variables. Let the random variable D equals L minus C be the difference between the lid's diameter and the cup's diameter. Describe the distribution of D. Well, since it's normal, right, the shape is going to be normal for the difference. And we could just use the rule, right? The difference in their means is just going to be the difference of the L minus C, which is 3.98 minus 3.96, which is 0.2 inches, right? So the average difference in the size of the two lids is going to be 0.2 inches. Well, what's the variability going to be? Well, if we know that the standard deviation of L is 0.2, we need to take the variance, which is squaring it, and then adding the variance of C, which would be 0.1 inch, and we square it. When we take the square root, we get a variance of 0.0224 inch. Okay, so like the difference, right, is going to be vary by 0. An average of the standard deviation, sorry, is going to be 0.0224 inch. So for a lid to fit the cup, the value of L has to be bigger than the value of C, but not by more. Actually, that's the top of the drink. Sorry, so it's lid versus the top of the drink. For the lid to fit the cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inch. Find the probability that a randomly selected lid will not fit on a randomly selected cup. Okay. So it has to be bigger, right? But not by too much. So it has to be like if you were to use like your technology, your lower bound has to be Wait.